All right, we're working in the last lesson of this unit dealing with quadrilaterals. This is probably the only lesson that does not have a cover sheet for you to write down properties because we're not working with learning new specific properties. All right, in the top box, we see that right triangles are in certain quadrilaterals. The directions say circle all of the quadrilaterals that will have right triangles. So take a second, think about it. Which quadrilaterals have right triangles in them? And we're back. Okay, so rectangles do. Okay, why? Because a rectangle, remember, has 4 right angles. So if I were to draw a diagonal here, I am now making a right triangle right here. Okay, we also know that rhombuses do because remember, where do you see right angles in a rhombus? It's not in the sides, but it's at the diagonals. They form perpendicular, they cross perpendicular at 90-degree angles. So here's a 90-degree angle, so I've actually formed 4 different right triangles, all of those inside ones. Okay, and the last one would be a square. Same thing, a square has 4 right angles. So if I draw a diagonal, I have right triangles right here. Okay, so square, rectangle, and rhombus are the 3 shapes, the 3 quadrilaterals that have right triangles in them. And we are going to use that concept today to help us solve and find missing side and missing side lengths and missing angles. All right, so our directions tell us we've worked with some right triangles in quadrilaterals in the past. Let's start there. Okay, we've done it in squares. So example number 1 says ABCD is a square where AF is equal to 7 centimeters. The directions are to solve for x, and we see x is a side length. Okay, a couple directions given to us. Number 1 says mark the right angles in the quadrilateral. All right, well, where are our right angles? We know that a square has 4 right angles on the sides, at the corners. So let's mark them. Step 2 says if the diagonals are perpendicular, mark the right angle where the diagonals meet. There are 2 different examples where that happens. It happens in squares and in rhombuses. The diagonals meet at 90 degrees, so really all of these are 90-degree angles, and I could draw one each time. You don't need to draw all 4, but I'm just showing you that they're all there. It says determine any other angles if possible. Okay, in a square, since all the angles are 90 degrees, and since the diagonals bisect the angles, okay, that's one of the properties, bisect means cut in half, what's half of 90? It's 45. So all of these smaller angles, and we don't need to label them all, but all the smaller angles are 45. Now, super important, that's only true in a square. I can't tell you how many times I've seen people do that to a rectangle on a test. Not true for rectangle, only for a square. All right, now our last step says use the Pythagorean theorem, the special right triangles, or trig to find the variables. So guys, this is not new. We know Pythagorean theorem, special right triangles being 45, 45, 90, or 30, 60, 90, or we can use trig. So it all just depends. In some cases, you may find there's more than one possible way to find a solution. You're just going to use what works for you and what you're comfortable with. Okay, so my directions down here say find x. Well, I know the angle measure is 45, 45, 90. So I could use trig. It's a 90-degree angle. I could use, well, they're all 90s. Never mind. Just kidding. I could also use Pythagorean theorem. I know 2 side lengths. If this side is 7, what's this side going to be? It's also going to be 7 because I have an isosceles triangle right here. The 2 base angles are congruent, so that side's congruent. So I could use Pythagorean theorem. 7 squared plus 7 squared equals x squared. I could use special right triangles. Okay, here's my 45, 45, 90. 1, 1, radical 2, fill in what we know, 7, 7x. So I could use Pythagorean theorem, I could use special rights in this case, or I could use trig. Okay, from my 45-degree angle, draw my person. Okay, I'm going to use this angle right here. I know the hypotenuse, and I know the opposite. So I'm going to do sine of 45 equals opposite, which is 7 over x. Any method you want is fine. Okay, I'm going to use Pythagorean theorem. Doesn't matter to me what you use. Key thing is I'm finding the hypotenuse. It's the one across from the 90-degree angle. So 49 plus 49 equals x squared. X squared equals 98. I take the square root of both sides, so I get the square root of 98. Or if you did it, if I simplify this, I would get 7 radical 2. If I did the special right triangle, they're all equivalent answer. or 9.899 if I went the decimal route. Okay? All those three answers are the same, just different forms, and all three methods of solving it would have worked in this case. Make sure that whatever your final answer is, you throw the units on, it is 7 centimeters. All right, on to the next one. Oops. Our example 2 says find PT in a rectangle HTAP. So PT is a diagonal. Okay, I'm going to find my diagonal. So our direction said first mark all the right angles. So here, I got one here, I got one here, and I got one here. In a rectangle, do my diagonals intersect perpendicularly? Do they form 90-degree angles? No. Okay, but let's fill in missing side lengths. If this is 15, so is this, because opposite sides are congruent. If this is 8, so is this. I am trying to find PT. Okay, well, I have a triangle right here. I'm going to outline it in black. And I know 2 of my side lengths. I do not know the angle measures, guys. You cannot assume it's 45. Okay, it doesn't. The diagonals do not bisect those angles. So in this case, I'm not going to use trig because I don't know an angle for sure. I'm not going to use special rights because I don't know my angles. But I do have 2 side lengths, so we are going to stick to Pythagorean theorem. I am finding PT, which is my hypotenuse. So 8 squared plus 15 squared equals x squared. So 64 plus 225. X squared equals 289. Take the square root on both sides, and I get 17. That's my answer. Okay, all the stuff we've done before, we are just looking for right triangles to solve them. Next example, let's take a look at our new quadrilateral. So we're going to talk about rhombuses, rhombi. All right, it says ABCD is a rhombus. Given ED is 6, AD is 10, solve for x. So once again, our directions tell us to start by marking our right angles. Well, in a rhombus, the only right angle we know is where the diagonals intersect each other. They intersect perpendicularly. So I could draw a right angle in all 4 locations. I don't need to. 1 is sufficient, but know that they're all there. Okay, now I'm finding x. I'm finding an angle measure. So there is only one method that works for this one. To find an angle measure, we use what? Trig. Okay, so I'm here. I'm drawing my person because this is what I'm finding. X right here. But I only have 1 side length. But don't worry, guys. What is true about all the sides in a rhombus? They are all congruent. So if this side is 10, this side is 10. This side is 10. This side is 10. Likewise, the diagonals. They bisect each other in half. Now, they're not necessarily all congruent, but something to think about. They bisect each other if we need to do that. I know that this one for sure is 6. Okay, so let's take a look. I have side lengths. I have 2 sides right now. So from here, I'm going to use the opposite and the hypotenuse. So which trig function deals with opposite and hypotenuse? Sine. So the sine of x equals the opposite, which is 6, over the hypotenuse, which is 10. So remember, whenever you're finding an angle measure, we do the inverse. So the sine of -1 is 6 divided by 10. Type that into your calculator. And I'm going to get... Sorry, I was looking at the wrong page. I'm going to get 36.869 if I truncate after 3 numbers, degrees. Okay, using your units here, degrees. All right, so once again, in a rhombus, I know all sides are congruent. I also know that I can use trig here. I also know that my diagonals intersect at 90-degree angles. Okay, on to the next one. All right, the directions say find the value of x and y in the rectangle below. Now, guys, just a heads up, something didn't print on your sheet that we need to know for this problem. We need at least 1 side length. So let's go ahead and label TH7 in both examples. I'll move the screen up when we get down to the second rectangle. Yeah, that didn't print, but that's okay. All right, so let's start by finding x. Actually, let's start by finding y. It's a little bit simpler. So use the top rectangle for y, and they'll move to the bottom rectangle for x. So here is y. Okay, my right degree is already marked for me, my right angle. So here I have a right triangle. Okay, now I only know one side length, so Pythagorean theorem won't work here. Likewise, I don't know my angle measure, so I don't know if it's a 30, 60, 90, what. So I'm not going to use trig, so I'm not going to use special right, so I have to use trig. But we do need an angle measure. Okay, we can find the measure of angle 1 and 2. Why? Okay, so we're pulling in all of our characteristics here. In a rectangle, the diagonals bisect each other, and they're congruent. So if you remember, that means all 4 of these little pieces are the same measure. And I'm looking at these 2 right here. If those 2 are the same measure, that means that this smaller triangle, while it's not a right triangle, it is isosceles. So that means that the angles 1 and 2 are the same measure. So I'm going to do 180 minus the 52, okay, because this, and this are going to add up to 180, and I get 128. And I can do 128 divided by 2 and get 64. So the measure of 2 and 1 is 64. Now, I'm not going to look from angle 1 because that's part of that right angle. I still need to be looking at the bigger triangle, the right triangle here. Okay, so I'm going to look from angle 2. All right, so from here I know I'm looking for the opposite and I'm looking for the adjacent, not the hypotenuse. So the opposite and the adjacent is tangent. So the tangent of 64 equals the opposite, which is y, over the adjacent, which is 7. Multiply both sides by 7. We get 7 tan 64 equals y. And we can type that into our handy-dandy calculator, truncate it after 3 decimal places, and we get 14.352 units. There aren't any provided, so we can just put U for units. All right, let's take a look at the next one. Same information, but we're finding x. X is length TS. Okay, it's the length TS, which is half of my diagonal. Now, here is my right angle right here. So guys, I need to use that entire triangle, just like we did before. But the problem is x is only half of the diagonal. So I have to keep that in mind. So what I'm going to do, the best method to do here, okay, because I can't use a smaller isosceles triangle because it's not a right triangle. So the best method to do is to use this whole triangle, find the length of TP, which is that entire diagonal, and then do what to it? Divide it by 2, okay, because x, can't see it anymore, x is the length of TS. It's 1/2 of the entire diagonal. So remember, the diagonals in the rectangle are congruent and they bisect each other. So I can find the whole diagonal and cut it in half. So we already figured out this measure was 64. Okay, it's the same concept. I can use this isosceles triangle right here to help me find that. So from there, I'm going to looking at the hypotenuse and the adjacent. So I'm using cosine. So the cosine of 64 equals adjacent, which is 7, over the hypotenuse, which for right now we'll call that whole thing b, so we're not getting our variables confused. All right, multiply both sides by b. Divide by the cosine of 64, and I can type that into my calculator, and I get b to be 15.968 units. Now that's not my final answer. That is a measure of T. I don't know what letters down there. TP. I want TS. I want half of it, so I'm going to divide that by 2. All right, so if I divide that by 2, I get my x, and I get 7.984. And that's my answer. So we're tying in all of our properties here, guys. We're tying in our special right triangles, our Pythagorean theorem, and our trig. Okay, let's take a look at the next page. The next 2 pages are practice for you to do. So I'm going to pause the video, and so are you, and you're going to take about 10 minutes and work through these. When you're ready, press play. Look at the answers. If you got something right, I'm going to explain each one, but if you got something right, move on. You don't have to listen to the explanation. Okay, but if you just copy down what I write, you're not giving it a shot on your own. You need to actually try them. All right, so please go ahead and pause the video now. All right, take a look. DAE is 90 degrees. Just kidding. Why did I write that down? Hold on. Sorry, guys, it's 58 degrees. Just kidding. All right, so in that little rectangle or triangle, I have, this is a 90-degree angle, that's 32. Added them together, subtracted it from 180. to give me my third angle down there is 58 degrees. All right, BD is 24 degrees. Why? Well, the diagonals bisect each other, so if DE is 12, the whole thing is 24. I double it. DBC is 32 degrees. Why? Diagonals opposite each other are congruent, and they're bisect in half. So if that's 32, each piece over here is 32 also. AB is 13 inches. Let's take a look why it's a rhombus. Okay, all sides are congruent in a rhombus on the outside. And then AE is 5. Oh, I use my Pythagorean theorem to get me that. Okay, if the outside is 13, this guy was 12, to find AE right here, so 13 and 12, I did my Pythagorean theorem and I got 5. All right, we are finding X. Okay, same thing. I could label, if this is X on here, I could label this one 41 because all the outside sides are the same length. I could label this 40 because this diagonal is cut in half. So if this half, BE is 40, so is ED. So now I have two side lengths. So from here is my person. I have the adjacent and the hypotenuse. So it's cosine. Cosine of X equals 40 over 41. Second cosine on my calculator, I get 12.680, so 12.68 degrees. All right, down here, multiple ways you could do it. Okay, I didn't give the decimal form for the answer, but these are equivalent. So the square right here is a right angle, right here is a right angle. A couple ways I did Pythagorean theorem because I knew if this was 6, so is this one, because in a square the diagonals are congruent and they bisect each other, so all parts are congruent. So I could have done Pythagorean theorem. You also could have set up special rights here because in a square, just a square, guys, well, in a rhombus, the diagonals bisect the angles. So if those are 90, all those smaller angles are 45, okay? And then the last one was the last rectangle example we did. You were asked to find X, which is half of the hypotenuse. So I did cosine of 75 equals the adjacent, which is 8, over the hypotenuse, which I left as H. I solved, I got 30.909, and then I had to divide it in half because I just wanted X, which was E to C, not the entire thing. All right, we are done. We will do more practice in class. Go back and look over any parts you need more clarification on.